All right, today we are going to talk about using our congruent triangles. So we've talked about proving triangles to be congruent. Today we're going to take it one step further and use those triangles to show that we have other parts congruent. All right, before we get started, let's write all the congruent parts we know if they tell us that triangle ABC is congruent to triangle DEF. How many statements are we about to make?
3.
6. Because we have how many pairs of sides? 3 pairs of sides, and how many pairs of angles? 3 pairs of angles. So we are about to make 6 statements. You don't have to number them, but I'm going to. 4, 5, 6. Somebody give me a pair of congruent somethings. Ari? Angle A is congruent to angle D. Brianna? Segment AB is congruent to segment DE. Good. Who else? Maddie?
Angle B is congruent to angle E.
Angle B is congruent to angle E. Ataya, did you have one?
Yeah. Segment BC is congruent to segment EF.
Segment BC congruent to segment EF. Any other new volunteers? Caleb? You volunteering?
Yeah, hold on. Let me figure it out real quick.
Okay.
C and F are congruent.
Angle C and angle F are congruent. I agree. Micah, did you have our last pair of sides?
Nope.
Okay. Deidreana? Good. Segment AC is congruent to segment DF. All the sides, all the angles. What about the 5 ways to prove triangles congruent? I'll tell you what's one.
Side.
Side is one of them. Micah? Side angle side is one of them. Maddie? Hypotenuse leg is one of them. Kara? Good. Angle side angle is one. What's our last one, Deidreana? Angle side. Is that not what you said? Okay, that's what I thought. All right, questions, concerns about these? So if what we've done so far with the triangles being congruent was pretty easy, which honestly, the proofs overall went pretty well for most people. Some people lost like partial credit because it wasn't perfect, but overall the proofs went pretty well. And if that's the case, then this next part that we're getting into is going to be pretty easy because it's just like adding one more step onto the end of what we've already talked about. All right. There we go. Once you show 2 triangles congruent, all of their corresponding parts are congruent. So this abbreviation CPCTC stands for corresponding parts of congruent triangles are congruent. Yes, we'll say it a couple more times. Corresponding parts of congruent triangles, or really any congruent figures, but we're doing it with triangles, are congruent. Which means if you prove 2 triangles to be congruent, let's say using side, side, side. You use side, 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 you said your triangles were congruent. Then you can also make statements about the pairs of angles being congruent. Once you state two triangles are congruent, you can talk about any pairs of corresponding parts being congruent. That's what CPCTC allows us to do. Questions, concerns, or need more time filling in those blanks? Okay? Big note, you must show triangles congruent using one of our 5 ways before using CPCTC. So, of course, as you probably expected, we are going to be doing some proofs today. Statements, reasons. Of course, starting them off, we need to list our givens. CV. Okay, we've got a pair of congruent sides. I'll go ahead and mark those. We're told that D is the midpoint of segment AC. So the whole goal here is to prove that we have some congruent angles inside of our triangles. But before we can do that, we have to prove the triangles congruent to each other, which is what we've been doing before. Adriana, you got an idea?
Can we talk about the bisector?
We sort of have a bisector. They didn't use the word bisect, so I wouldn't use the word bisect. But what do you mean?
So I was saying like DB bisects ADC. So because I like it on
That is not where I would go with it, because I think that we aren't quite told that with the whole bisect idea. Yes.
Since D is the midpoint of AC, then AD is congruent to DC.
Perfect. Okay, they didn't use the word bisect, so technically midpoints bisect segments, but that doesn't tell us anything about the angles. Does that make sense? We know what Atea said, that AD is congruent to DC, but I wouldn't talk about any of those angles in there because they did not give us an angle bisector. So AD congruent to DC, we use the definition of midpoint. Of midpoint. Caitlin, you got an idea for us?
Would you say segment ED is congruent to itself?
By the
Reflexive?
wonderful reflexive property tells us that BD or DB, whichever way you want to say it, is congruent to itself by the reflexive property. Okay. Now we have enough information to do what? Well, we can't do the proof statement, but what can we prove right now? Okay, we can prove the triangles are congruent. So we're not ready for our last step. We can say that these triangles are congruent. Now, before, they always gave you the congruence statement because that was the end of the proof. This time, you have to come up with your own congruent statement about the triangles. So that means you name your first one. So what do you want to name your first triangle? ABD, sure. If you named it differently, that's technically fine as long as you named your second one appropriately. So if we are talking about triangle ABD, then our other triangle should be what? CBD. So remember, the corresponding sides should be matching up with each other. So like AB was congruent to CB. Those two letters came first. DB or BD congruent to BD, of course. Those letters match up. And why were we able to say that? Side, side, side. Now that we've used side, 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 we can use the CPCTC, corresponding parts of congruent triangles are congruent. That's what allows us to then talk about these angles. Angle ABD is now congruent to angle CBD. Our reason for that is the CPCTC. Corresponding parts of congruent triangles are congruent. So this is not a whole lot different from what we've been doing. We're basically doing the same thing we were doing and then adding one more step at the very end. Questions, concerns?
No.
We're ready to move on to the next one?
Yes.
Some of us are. Okay. Let's set up our statements and reasons. Starting off with our givens. Angle B, angle C are right angles. And AC is congruent to BD. That's all given to me. Okay. This particular proof, it might be helpful to split up your triangles. We haven't done a lot of proofs where the triangles overlap. So what I mean by that is to draw these two big triangles pulled apart from each other. So one of my big triangles would be triangle ABC. So it might be helpful to draw that triangle on its own, not overlapping the other one. What's the other triangle? The other big triangle. DBC is the other big one. So if it helps you, you could draw those separately from each other. I'm running out of room on the slide here to be able to fit everything on it, but D, B, C. Do we all understand what I mean by pulling them apart? Draw them separate from each other.
Where did E come from?
So the E kind of disappeared, right? Because now those don't overlap, so there's not an intersection point. So you could label point E on the middle-ish of those. We don't know that it's directly in the middle. Kind of looks like it. So if you want to show point E, you can, but none of our givens or our proof statement use point E, and I don't think we will either. Does that make sense? Other questions about pulling the triangles apart? Okay, so now that we've done that, let's think about what we could mark. So they told us that we've got right angles. We could mark those. They told us that AC is congruent to BD, so I can mark those. Now, if we've got right triangles and we have the hypotenuses congruent, what does it look like we might be headed for? HL. But we're missing the leg piece of that. Is there a way we could get that piece put in here? With which side? Good. You'll notice we drew side BC twice. We drew it along the left side of both of these. They overlapped each other there. So we could say that BC is congruent to BC. It was used in both triangles. It was just used a little bit differently than we've used the reflexive property before or seen it in a diagram before. Questions about using reflexive there? Okay, so now we have enough information to show that our triangles are congruent using what theorem? Hypotenuse leg. So we know on step 3 we're using HL as a reason. Now we just have to come up with those triangle congruence statements. So tell me how you want to name your first triangle.
I have a question.
Okay, question first.
Why didn't you say that BA was congruent to CD? Why was that not?
Why didn't we say what?
That BA was congruent to CD.
So that's actually what they want us to prove,
Oh,
right? That's our AB congruent to CD. We don't have any information about AB and CD or BA and CD right now. We couldn't use those right now. They didn't label them for us. They didn't tell us they were congruent. That's actually what they want us to end up saying at the bottom. Does that make sense?
I didn't.
Yeah, so we definitely don't have enough information until we do all this other stuff to talk about them. It's a good question, though. You wouldn't want to use AB congruent to CD somewhere earlier in your proof. That's where you're trying to end up. All right, back to our triangles. How do you want to name the first one? ABC, sure. You don't have to name it that way, but if you do, how do you have to name your second one? Good, DCB. I think a while back I mentioned the fact that sometimes your angles might seem out of order just by looking at the letter. Okay, for example, we used a B in both of these and they didn't line up with each other. But that B was a different angle. In the first one, it was a right angle. In the second one, it was definitely not a right angle. Okay, so just because they have the same letter doesn't mean those letters are always going to line up with each other. All right, now that we've used HL, we can go ahead and say that AB is congruent to CD. Why? CPCTC. Corresponding parts of congruent triangles are congruent. Any other questions or concerns about example 2 right now? Okay. Let's go on to number 3. Statements, reasons. Start off with your givens. AB perpendicular to BD. BD perpendicular to DE. And BC congruent to DC. Lots of givens. The one where they said congruent, we can go ahead and mark BC congruent to CD. I'll mark that one right away. Okay. Now what?
Side angle side. Not now, but like, is that what we're using?
I don't think so. Kara, what do you think?
Use perpendicular statements to make right angles.
Good. We can come up with right angles when we have perpendicular lines. So what angles are going to be right angles? Good. Angle B and angle D are right angles. Bless you. So that was the definition of perpendicular lines. We can mark those in there. What do we know about all right angles? They're congruent, so that's where I would go next. I would say that we know angle B is congruent to angle D. Now, you don't have to do that when you're using HL, but spoiler alert, we're not using HL here. So, all right angles congruent. Okay, we're getting closer. We've got a pair of angles and a pair of sides. Any other ideas here? Kara? Vertical angles. Now, before we were listing out that we had vertical angles from the diagram, at this point in our geometry careers, if you just state what your vertical angles are and that they're congruent by vertical angle congruence, I'm fine with that. We kind of have moved past that part. So if you look at your diagram and see you have vertical angles, tell me what those angles are, and you better not say angle C congruent to angle C. My vertical ones. We got to be able to list our angles with 3 letters. DCE is one of them. Angle DCE is congruent to which other angle? BCA or ACB, whichever way you want to name it. And our reason would be vertical angle congruence theorem. If you are in the habit of putting in the step that there are vertical angles that you assume from the diagram, that's fine. I'm okay if you keep putting that step in there. I'm just saying that I don't need to see it anymore. But I would need to see this vertical angle congruence theorem step. Are we clear about my expectations? Okay. Then I can go ahead and mark those. Congruent. What could I do now? Prove the triangles are congruent using what? Angle, side, angle. So I know I'm using angle, side, angle. Now I just have to worry about how I'm naming those triangles. How do you want to name your first one? Okay, I heard DCE first, so that's what I'm going with. If I name the first one DCE, the other one has to be angle B, triangle BCA, by side, angle, side. Last step.
Proof.
Your proof statement. We could now say that BA is congruent to DE by CPCTC. Questions? Concerns? Warm, fuzzy feelings? I feel like it's getting warmer in here. Is it just me? It's getting, yeah. I think it's when the door is open, it gets cold in here, and then when the door stays closed, it gets hot. We just can't get it right. All right, we've got a couple more proofs that we're going to talk through.
Oh.
Maybe they're a little challenging. We'll see. Maybe they'll be easy. I don't know. Well, I guess maybe I'll throw it out. We'll do like a... Do we want to do a couple more together, or do you want to do some different ones on your own? We'd rather do them together? Okay. Statements, reasons. This is another one where when they overlap, I would sometimes recommend trying to draw them separate from each other. But let's just see what we're working with, and then we'll see which triangles we might need to pull apart. SPT congruent to angle RQS. Okay, all of this is given to me. It actually doesn't give us a whole lot, in my opinion. So ST congruent to RT. And then we know that angle SPT. Where in this diagram, tell me like up, down, left, right, where do I find angle SPT? Top left. Good. So SPT is this little one, top left. What about RQS? Top right. Okay, given what we were given, what segments that are drawn here do you think I probably don't really need?
TQ and TP.
Top one.
I would say TP and TQ are going to be important because that encloses this triangle. PQ up top, right? We got nothing around there. So I'm just going to kind of ignore that. I know you can't really erase the ink on your page, and I'm not expecting you to get out white out, but just for the sake of this proof, it's important to know that we don't necessarily need every segment. What other segment could we probably do without? SR. Okay. Can we go without SR? So we don't need, I think eventually we will need SR. We don't need it right away though. I don't think we're going to use PQ at all. Okay, so let's first focus on, maybe I'll just like lightly cross that out for right now and then we can bring it back. So for right now, I think we need to focus on these two big triangles on the sides. So let's prove those congruent. So what other piece of information do I need before I could say those triangles are congruent? Ariana? Good. Angle PTS is congruent to angle QTR. How did we know that? Good. Vertical angle congruence theorem. We have vertical angles. They must be congruent. So that's helpful to us. Now, looking ahead, we want to be able to say that PR, which is this whole long thing, is congruent to QS, which is that whole long thing. So right now, they told us some baby pieces of it. But then eventually we're going to need to talk about PT and TQ. Eventually. So let's just not get too far ahead of ourselves. What do we have enough information to prove now? We can use angle side to say that our triangles, big ones left and right, are congruent. So name your first triangle. PTS is congruent to which other triangle? QTR. Okay. That was angle side. Are we all okay so far? Okay, now I'm going to erase some of this up here just so that we can see things a little more clearly. We're kind of done with those angles, so I'm going to take them away. Our goal is to say that all of PR, this whole thing, is congruent to all of QS. That is our end game here. So what I was saying just a couple minutes ago is that they gave us little sections of it congruent. So what other segments would it be helpful to talk about before we can get to our proof? Good, PT and TQ. It would be helpful for us to talk about those. And luckily, we could say that PT is congruent to TQ or QT. Why are we able to do that now? What was the whole big idea today? CPCTC. We proved those triangles congruent, so therefore other corresponding parts of those triangles are congruent. Now we are not done with this proof, of course, because we didn't get to our proof statement yet. But now we've got ST and RT. They told us that in our given. Okay. This is actually going to be a throwback to way back when we did something like this. I'm going to say my next statement should be that PT plus TR is equal to PR. Why am I allowed to say that? Segment addition.
I'll figure it out later.
Okay. I would also... We could also talk about the other segment addition. What would my other segment addition be? Plus TS is equal to QS. We see where we're headed with this? Okay, so then we're going to have to substitute some stuff in, right? So we could use substitution to say, instead of using PT and QR here, we could use QT plus TS is equal to PR. So I substituted, instead of using PT, I used QT. Instead of using TR, I used TS or ST. So that was a substitution. And then the last one, you can kind of go substitution or transitive with it. But finally, we could say that PR is congruent to QS. And again, it kind of could go either way. You could argue substitution again. Oop, that's not. I'll write it down below. Substitution or transitive would be fine there for me. That one, I will agree, was a little bit challenging. Do we have questions about it? Mixing some of the old with some of the new. Okay, I think I will leave that last challenge up to you. And perhaps there could be some bonus points involved if people get it perfectly correct. So we'll let that one just sit in your brain over the weekend. You got a long weekend. I bet some of you could figure that out. But if I'm going to give you bonus, it's going to have to be like perfect. Perfect. So if you want to work on that right now, you can. Otherwise, we do have homework. I better see you being productive some way, somehow. Otherwise, I've got a separate worksheet that's just got proofs on it if we need something to be productive with.